And theorem 10.8 is the perpendicular chord bisector converse. But be careful, like if you try to take the converse of the perpendicular chord bisector theorem, first of all, that's in part 1, but if you try to say something like, if the diameter bisects the chord and its arc, then the diameter of a circle is perpendicular to a chord, would not be completely correct. Here's what the perpendicular chord bisector converse states. Okay, if you have a chord of a circle and it's the perpendicular bisector of another chord, so here's a chord of a circle. If it's the perpendicular bisector of another chord, so here's the other chord. Let me label these. So if chord PQ is a perpendicular bisector of chord RT, 1, it would be perpendicular. 2, it would cut that chord into 2 congruent parts. Then that chord that is the perpendicular bisector has to be a diameter. So here's the perpendicular chord bisector converse. Again, 1 chord of a circle is the perpendicular bisector of another chord. So the first chord, which is the perpendicular bisector, has to be a diameter. In other words, it has to go through the center of the circle. So if the center is C, then chord PQ contains center C, which means it's a diameter. And then the last theorem for 10.3 is the equidistant chords theorem. So the equidistant chords theorem states if you have 2 chords in a circle and they're congruent, then they're equidistant from the center of the circle, and vice versa. So we're going to write it as a biconditional statement. But I could show you in the diagram here. If you have chord AB congruent to chord DE in the circle, then they're the same distance away from the center. Recall that the center is a point. So really you're calculating or figuring out the distance of a point to a segment, which is similar to figuring out the distance from a point to a line, because the distance has to be a perpendicular segment from the point to, in this case, the segment. So these distances would have to be the same. And since the equidistant chords theorem is written as a biconditional statement, remember that it could go both ways. So if you know that 2 chords are the same distance away from the center of a circle in a circle, or congruent circles, then those 2 chords would be congruent, because you can switch each of these statements around for a biconditional statement. In the next video, we'll take a look at some examples trying to apply each of the theorems and the converse.